Hi guys, welcome to the next lesson. In today's lesson, we're going to talk about addition postulate. Addition postulate, this is 1.4. We will be looking at both segment addition and angle addition. Now these are postulates, a little bit different than theorems. We will be assuming that these things are true, okay? So first here we have the segment addition postulate. It starts off by saying if 3 points A, B, and C are collinear. Now let's just stop right there and get us a picture. Let's say we have a segment made from these 3 points, A, B, C. And those are collinear because they're all on the same line. Let's just label them A, B, C. And then it says, and B is between A and C, and we have that B is between. Okay. Then what? What can we gather from this? Well, the postulate is going to tell us that segment AB plus segment BC will equal the entire segment AC. And this should make kind of intuitive sense. It's basically saying if we take the first part and add the second portion to it, that we end up with the entire segment, okay? So if we have 3 points that are collinear and there is 1 point between the 3, then we can assume it's true that the first piece plus the second piece will equal the entire segment, okay? That's what we get from segment addition postulate. AB plus BC equal AC. Let's take a look at a few examples. We see here a segment, 3 collinear points, B, A, T, BAT. We do see that A is between B and T. What else do we have? BT, that's the length of, or the distance from point B to T. Let's see, colors can kind of, there we go, now you can see that. From B to T is 36. That's given to us that the entire thing is 36. And they want us to find BA, what's this segment length, and also AT. So given BT is 36, we want to go back and find BA and AT. Now there is some information on here that we need to add in, so make sure you put this on your notes as well. That BA has an expression, it's equal to 8x minus 14. And AT is 2x, so make sure you add that in as information. That should have been there on the handout and wasn't, so put that there. Okay. So we have values for every piece, every segment. Once again, BA is 8x minus 14, AT is 2x, and the entire segment BT is 36. We are asked to find the value of BA, the measure, and AT. So let's use the segment addition postulate. It tells us the first segment, which is BA, plus the second segment, and this is without any gaps, see, they are touching, plus the second segment, AT, will equal the entire segment BT. okay? So make sure you set it up every time using your letters, your segments, write down the equation. And then once you have this basic formula, you can go back, substitute the values in. So what was BA? BA was 8x minus 14. Plus AT was 2x equals BT 36. And I tell you guys all the time, this is the end of the geometry. The geometry is over. You now have an algebraic equation you need to solve. Okay, so you just need to solve this using basic procedure. Let's go ahead and combine like terms. 8x and 2x gives us 10x minus 14 equals 36. Okay. And we just need to continue on solving this equation so that we can get x and then go back and solve for BA and AT. So at this time, we want to add 14 to both sides. That's going to give us 10x equals 50. 36, 14, check my math. 10x equals 50, and then divide both sides by 10. X comes out to be 5. So that's good for us to use segment addition, solve this equation, x equals 5, and now we just need to go back and find the value of BA and AT. Now that we know the value of x, all we need to do is go back and substitute this in to find the values of BA and BT. Let's go. BA was 8x minus 14. So we want to take the x out and replace that with 5. So that'll be 8 times 5 minus 14. 8 times 5 is 40. And 40 minus 14, check my math, is 26. 26 for BA. Also need to find AT. AT, the value was 2x. Well, we know x is 5 now, so 2 times 5 is 10. And now this should make sense. This also should basically prove the postulate to you in a sense, right? Because, or at least prove that we did it right, because 26 plus 10 is 36. So this all worked out. Make sure you have this example down in your notes. We're going to move on to the next one. So we have points M, A, N, all collinear, spelling out man here. So hopefully you caught that, Batman and all the Batman symbols. So we are given MA is 5x minus 3. Let's go ahead and label that. Just this segment, MA. And we know AN is 30. MN, need a value for that, and we're going to be finding X. Make sure that you add in to your notes that the value of MN is 8x plus 6. So this entire segment is going to be 8x plus 6. And get ready to set this up. Make sure you remember that postulate tells us first piece, right? MA plus the second piece equals the entire thing. And you can see that clearly when we color code it, right? The first piece, that first segment plus the second segment indeed equals the entire segment. So let's write that down in segment notation. That means MA plus AN equals the entire segment MN. And I suggest you always start there, writing out the segments, creating your formula. This is your formula. And when you have that down, all you need to do is substitute the values in. So MA is 5x minus 3 plus AN, which we know is 30, equals MN, which is 8x plus 6. Once again, guys, we have completed the geometry. Algebra is taking over at this point, and so we just need to solve this multi-step equation. Do have videos for you available on the channel if you need extra practice and review on solving equations, so you can check those out. But let's go ahead and solve this by combining like terms, getting each side completely simplified. Over here, 5x is the only x, so we'll leave that alone for now. For this -3 and the 30, we can combine that. 30 minus 3 is positive 27. And 8x plus 6, that side is already simplified for us. So we have an equation with variables on both sides. We don't like that. We need them to be together. So let's pick one to move. I will move the 5x over. It's positive. We'll subtract it to the other side. And so it'll be 27 equals, remember we're subtracting 5x. So 8 minus 5 gives us 3x plus 6. And now that looks better, right? With every step, it looks better and better. We want to subtract 6 from both sides. That'll give us 21 equals 3x. And dividing everything by 3x is 7 for this problem. Okay. And that's all they wanted us to find. Of course, they could have asked us to find the value of MA and MN, but they didn't, so we won't dwell on that, okay? Let's move on. All right, guys, for this section, we have a little bit of a pause and cut to algebra for a moment, just to make sure those algebra skills are good and strong, because we are going to need them going forward as we continue with the geometry. So you have 4 problems here. I would like for you to just kind of pause for a moment, work those out for like 5 minutes. And then when we come back and unpause, we'll have the answers for you. Again, if your answers, when you check them, are not correct, then we're going to need to spend some time reviewing how to solve equations. And I do have materials for you if you need to kind of use those resources to build those algebra skills. So let's pause for a moment. And then when we come back, those answers will be here for you. So you should see the answers to all 4 of those equations there for you. Number 1's in purple. Check your work, check your answer. You should have x equals 4 for number 1. Number 2 did not work out as a whole number. You have x equals -8/3, or as a decimal, -2.6 repeating. Number 3, x is 2. Not too bad. Check your work for that one. And then number 4 had a lot going on, but x turned out to be 9/2 or 4.5. So make sure all of your scratch work and everything is correct. If you made a mistake, of course, like I said before, there are things we can do to help you build those skills of solving equations. All right, we are going to move on now to the angle addition postulate. So the name sounds a lot like the segment addition postulate, and it's going to work pretty much the same way, but let's see what happens here. Follow along and add your notes. So if point B is in the interior of angle DOG, let's just kind of stop right there, get us a figure going. So we know we need an angle, and the angle needs to have these 3 points, but very important, the O is in the middle, so that's going to have to be our vertex. We need angle O right here. And then D and G, doesn't matter which one you put up top, does not matter. Okay, but now we have angle DOG drawn correctly, okay? Next thing, it says point B is in the interior. Well, you need to know where the interior is, all right? And the interior is going to always be inside of the angle, okay? So here where we have blue, that's the interior. Everything out here is outside, and we would call that exterior to the angle, okay? So we need point B to be somewhere in this blue shaded region, wherever you want it to be. So I'm going to put it right there as point B. Okay. And of course, we can draw another ray, okay? So we have a picture to represent this first part. If point B is in the interior of angle DOG, then what? Well, then the angle addition is going to apply. So what is that exactly? That means angle DOB, this first angle, okay? Angle DOB plus the next angle, it's right beside it, they're consecutive, BOG is going to equal the entire original angle that we had, which was angle DOG. So it works the same way, it's just angles. It's still saying the first part plus the second part equals the whole. That's all this angle addition is, just like segment addition, okay? So let's do a couple of examples. We've got given here the measure of angle MAT is 60. MAT, make sure you have the right one. MAT, A is the vertex here. This is a 60-degree angle. Okay, we're going to have to fill in MAH. Do that, that's the whole thing. But TAH is 4x plus 20. And they want us to find x. So we know angle MAH does measure to 140. Make sure you put that in there and all the information that you need, okay? And before we work this out, let me just go back and just brush up on a technicality here. Very important that you put the measure in front, because we're not, the angles, the values, the measures of the angles are what we're adding, okay? So just a little technical thing we need to do notation wise. You see how all of these have the measure of, okay? So following along with that, once again, the first angle plus the second angle should equal the entire angle there, okay? So let's write that down, write that formula out like we've been doing with the segments. We know the first one was the measure of angle MAT. Oh gosh, look at that M. Okay, we can't have that. Let's make that a little better. Okay, and that really is just a little bit better. So the measure of angle MAT plus the measure of angle TAH, right? We're following from the figure. Do not let the given information trip you up. It's the first angle plus the second angle is going to equal the entire thing, which is the measure of angle MAH. Okay, and it looks like a lot of letters, but you just need to know first angle, second angle, entire angle, and you want to substitute the values in. So we know MAT is 60 degrees plus the value for TAH was 4x plus 20. And that's going to equal MAH, which we know is 140. Solving this equation now, the geometry is over. Here's the algebra. We're going to combine like terms. 60 and 20 gives us 80. 4x is still there. 4x plus 80 equals 140. Okay, we need to subtract 80 on both sides. So we end up with 4x equals 140 minus 80 is 60. 4x equals 60, dividing both sides by 4, and x is 15. That's our answer for this one. X is 15, okay? And you can check your work if you wanted to. You could substitute this 15 in right here. 4 times 15 would be 60. 60 plus 20 is 80. And then you ask yourself, is 80 plus 60 equals 140? Absolutely. So we did that correctly, okay? We're going to move on to this next example. All right, next example here, we have another angle. Looks like it's being split by this ray and it's creating two angles here. Okay, but we know angle addition postulate tells us first angle plus second angle is going to equal the entire thing. So let's get that highlighted here. We have red plus green, of course, equals the entire angle there. All right, so making sure we can create this formula again correctly. The red angle is LOV. Measure of angle LOV. Plus, we need the green angle next, which is going to be VOE, the measure of angle VOE. That will equal the entire angle there, the big one, angle LOE. So what we want to do is take the given information we have here, take these values, substitute them into our angle addition formula. So let's find LOV, that would be 4x plus 1 that we need to replace that with, 4x plus 1. VOE right here, 5x plus 2. And lastly, LOE, we have 84. So again, geometry is complete. We need to solve this algebraic expression, or excuse me, algebraic equation. We need to combine like terms here, 4x, 5x, 9x, 1 and 2 gives us 3. And so we're looking at 9x plus 3 equals 84. Solving this for x, we want to subtract 3 on both sides. That's 9x equals 84 minus 3 is 81. and then divide both sides by 9. X is 81 divided by 9, 9. Okay, so X is 9. That's our first answer. And we're not done because this one asks us to go back and find the measure of angle LOV. Okay, so we want to find LOV right here. We know that value is 4x plus 1. So simply now just substituting the 9 in that we found, 4 times 9 plus 1. Come on, plus sign. Right, so that's going to give us 4 times 9 is 36, plus 1 more is 37. Okay, so the measure of angle LOV is 37 degrees. That's our answer there, okay? All right, that will conclude the notes for section 1.4 on addition postulates, both the segment addition and the angle addition postulate. I will see you over in the practice set in the next video where we'll be working through some more examples together, okay? Make sure you have this all in your notes. Bye, guys.